just to let you know, this webinar was supposed to be an Inventor R2 webinar. As I was preparing for it yesterday, I realized that during my preparation, or actually 33 minutes before I started preparing for this, Inventor R3 got released. So R3 is like an update to R2. So I thought I'll probably run this webinar as an R3 webinar rather than R2 webinar. So just a quick introduction about myself. I think most of you guys already know me, but I'm a qualified mechanical engineer. Been with the company for about 10 years now. More than 17 years of experience with various CAD programs. I'm also a guest lecturer at University of New South Wales and University of Technology, Sydney. I also get regular speaker at our annual conference called Autodesk University in Las Vegas. I've written a few books as well. This one here, Advanced Steel book. It's the latest one. It is going to be released in February because of the scheduling with the printer or publisher. It's going to be released in February next year. So let's look at quickly look at the agenda for this afternoon/morning. I'm going to first explain what is Inventor R3, where to download it from. I'm going to talk about the new features in Inventor R3. So R3 has got a couple of additional features over R2, so we're going to talk about R3. Then I'm going to talk in detail and demonstrate one of the main features of Inventor R3 or R2 called Shape Generator. So that's the agenda for today. And at the end of this, we are going to have, I'll open it for question and answer sessions, and then hopefully we'll wrap it up on time. All right, so first of all, what is Inventor R3? Inventor R3 is an update available only for subscription customers. So if you've got current subscription with Autodesk for your product design suite / factory design suite / building design suite / any other product that's got Inventor in it, you have access to Inventor R3. What does it actually do? It delivers a number of product enhancements and new features. If you do not have your Autodesk Inventor on subscription, you can still download the service pack. Service pack will get you the product enhancements, but not the new features. All right, so first of all, where to download Inventor R3 from? If you already have Inventor R3 installed on your, if you already have Inventor installed on your computer, on the lower right corner where you see the Autodesk Application Manager, which is actually a really cool feature in that got installed with the Autodesk product starting a couple of years back. Every time there's a new update for any of your installed Autodesk product available, it would show you a balloon there that there are updates available. So if you open Application Manager, you'll be able to see this in the Application Manager. You can see that on my machine, I've already installed R2 as well as R3. That's why it's showing us here status installed. If you do not have Inventor installed on your computer, in that case, you can go to your subscription account, so which is manage.autodesk.com. So when you go to manage.autodesk.com and you log in using your subscription credentials, on the left, you will be able to see product updates. When you click on product updates, what I filtered it based on recent and last month. So I can see the two updates here. If you haven't installed either of these two, you don't need to install R2, you can directly install R3. So R2 will not be required in that case. All right, so once we have figured out how to install R3, let's now find out what are the new features in Inventor R3. So the first new feature is what we call as ForceEffect. ForceEffect is a program that lets you create free body diagrams to simulate design options during the concept phase. This, in fact, used to be available on your tablet devices till a couple of weeks back. So on your iPad or your Android device, you could download a program called ForceEffect or ForceEffect Motion, where you could take photographs of things and then create free body diagrams and then apply loads and conditions to those. So that is now available inside Inventor as well. When you fire up Inventor and you go to the sketching environment, you'll be able to see the ForceEffect buttons there. What it also does is it lets you perform engineering calculation to determine the viability of your design concept. You can save the vector geometry and then open it as part or assembly skeleton sketches. There's a question here. For 2015 also, right now, yes, so 2015 also it is available. At this stage, they have released it only for 2016, but for 2015, there are plans to release this. What all features would be available in 2016, I'm not too sure about that at this stage. But as soon as we come to know anything about this, I will let you know. But at this stage, it is only released for 2016. I actually plan to take the questions at the end, so if you please hold on to your questions, that would be brilliant. So that make sure that all of us are able to finish it on time and then have some more time at the end for questions. All right, so quickly going back to ForceEffect. So once you have performed your free body calculations and you're tested the design and it's viable, you can then save the sketch, which can then be used as part sketch or assembly sketch. To quickly show you where it is available, if I jump over to Inventor now. So this is my Inventor model. So if I quickly start a new part file, and then I'm going to go into a new sketch. And these are my ForceEffect commands here. So I can create a new ForceEffect sketch. I can then modify it, link it or unlink it, and so on. This webinar, we are not going to talk about this in detail because, as I mentioned earlier, we want to concentrate on shape generator. So that was the first new feature in R3. The second one is improved intermediate data format workflows for your electrical and PCB diagrams. We've got now new content library for IDF components. You can also create your own custom IDF components and add them to your PCB library. The important thing is when I installed R3, the IDF component library was not turned on by default. For that, I had to go into my projects. So get started tab under projects, and here we go and say we want to modify our content center libraries. So down the bottom, I could see my IDF library here. It was listed at the bottom. So I had to turn this on. Once I selected it, it's now available for me to use the components. So the key is, by default, it was not selected, and I had to manually go and turn it on after installing R3. All right, the next one, which is one of my favorites, is Inventor Connected Design on A360. So if you do not know what A360 is, in Autodesk world, anything that's got 360 in it, that means it's cloud-based. A360 stands for Autodesk 360. With every subscription of your Autodesk product, you get 25 gigabytes of space free on A360. It's like your Dropbox. In the past, we were able to save Inventor models or any other program models onto A360 for viewing, whereas now it's become a lot more, a lot cleaner interface and a lot better to work with. So what is the connected design? It enables you to easily communicate or design your 3D models and share it with other members in your team for design reviews. The other members of your team could be using any device. They don't need to use Inventor. They don't need to be in front of a computer to be able to review your design. They can do that on the tablet device as well. It allows anyone to review the design on virtually any device, regardless of where they are. What it basically does is it creates a lightweight 3D viewable model that you can then publish on the 360. The whole concept is you control what you want people to see. So you can create either level of detail representations or shrink wraps, and then you can only share the components or leave the components that you want to be reviewed, and rest everything you can suppress. It automatically manages and tracks comments from collaborators and provides a central record of the time and date for each design share and comment received. So how does it really work? It's really simple. Within your Inventor screen now, after you've installed R3, on the lower right corner, you would see this particular button. When you click on this design share button, it displays this window on the right of your Inventor screen, which is connected design on a 360 window. All you need to do is you need to click on this button that says design share this view. When you do that, it displays this dialog box. It automatically gets the name of the assembly. You can add some comments here. And then all you need to do is type in the email addresses of the people you want to share your design with, and then click on Add. As soon as you do that, all the people that you have added all the people that you have added to this list will be listed here, and then you click on Start Design Share. On doing this, everyone that you have added to your design share team will get an email that you have shared a design with them. They'll be able to click on that email. It'll straight away take them to your A360 or their A360 drive and the A360 viewer window. Quickly jumping on to Inventor to show you how this works. Let me close this. So if I want to design share this particular model, I'll click on this button on the lower right corner. It says, what do you want to do? I'll say, I want to design share this view. I'll click on this. It displays this dialog box. I can add comments here. And then simply add the email addresses of people that you want to share this with. And then click Add. And then if I click on Start Design Share, this person would get an email straight away that I've shared a design with them. When they click on it, they'll be able to view this model, they'll be able to comment and things like that. If I did not want the entire design to be shared, I could simply go and create a level of detail representation where I can only show what I want to share. And as a result, the lightweight model will only include that bit and nothing else. So that's the design share bit. All right, the next new feature in Inventor R3 is IFC export. Starting Inventor R3 now, when you go to the BIM Exchange environment, depending on whether you are doing it from the part file or the assembly file. If you're doing it from part file, in the past the options used to be ADSK and RVT file. Now you'll also see IFC files. And same thing with the assembly. When you're exporting it from the assembly BIM Exchange environment, it'll show you ADSK as well as the IFC format. You can also click on model properties to take the model properties. At this stage, the workflow is that the IFC model that you're exporting will be taken as a single unit into Revit. You won't be able to break it down into individual bits. But at least we've got a start. We've got at least some basic IFC export from Inventor. All right. So the next one is Shape Generator, which is the focus of our webinar today. What is Shape Generator? Shape Generator is a tool that optimizes the geometry of a part to withstand the specified loading condition. So basically what it does is, it shows you a model by optimizing the shape of it and shaving off any unwanted material and thus reducing the weight. So it's basically making it a lightweight model and still able to withstand the loading condition and the boundary condition that you have specified. Once you've got the optimized shape, you can then promote that into your part environment and use that as a guide to remove the unwanted material. So basically, without further ado, let's actually get into Inventor and have a look at this stuff. All right, so let me close out of this. In my case, I've got this assembly here. I've got these two components on either side, basically taking a bit of load when this bucket is moved up and down. So what I've done is I've actually opened that part file separately. Once you've got Inventor R3 installed on your machine, in the part modeling environment, you would see this tab called Explore and this button called Shape Generator. When you click on the Shape Generator button, it takes you to like an FEA environment. Also displays this dialog box telling you what Shape Generator does and so on. You can click on Learn More to watch a couple of videos and so on. You can clear this tick or select this tick box if you do not want to see this dialog box again. So when I click OK, as you could see, it's like a pretty basic Inventor FEA environment. What I want to do is I want to now basically apply some constraints to it. So what I'll do is I'll go and say Fixed. I'll fix this face, and I'll apply a pin constraint on this face. So basically fixed one cylindrical face here and applied a pin constraint to this cylindrical face. The next thing I want to do is I want to apply load, because this is the hole where the pin would be inserted that would be taking most of the load. So I'll go to the force command, pick this face, and then I want to apply the load going down to start with. Let's say 5 tons, so 50,000 newtons. I want it to go down, so I'll make sure that I type in minus here. So, okay, and then it applies this load. So basically now I'm ready to generate my shape. However, we are going to look at a couple of other things. So the first thing I want to look at is preserve regions. For me, these holes are important because these holes are where this part would be assembled with the other components. So I'm going to go into preserve region, go in here and pick these cylindrical faces because I want to preserve these regions. I don't want these regions to disappear. And then finally this one. So looking at my browser tree, I can see that I applied a fixed constraint and a pin constraint. I preserved 3 faces. I also applied a load here. Before I click on Generate Shape button, let's quickly have a look at the shape generator settings. When I click on this button, it displays a dialog box. Basically, our design criteria is we want to reduce the mass by about 60%. You can increase or reduce it depending on what you want. Whether it can or can't do, you would be able to see that in the results. Then we've got mesh resolution. As in any FE environment, the mesh would basically decide how good your results are. Finer the mesh, better the results. The only thing is, finer the mesh, more time it's going to take to solve. I'll change this to 1, and when I click OK, it's basically now ready to generate the shape. I'm going to click on Generate Shape button. This process might take about a minute or so. It'll go through the process of generating my mesh and then testing for the load conditions, and then finally recommending an optimized shape. As I mentioned, it might take a few seconds. It also depends on your machine and your processing power and so on, and there you go. So based on the load that I defined and the boundary conditions that I defined, it's come up with the shape telling me that this shape is optimized for you. It's going to take all the loads that you want it to take and basically shaving off anything that we do not want. At this stage, it has not gone in and modified the component. It has only shown us what it thinks is, or what it thinks is the optimized shape for our loading condition. Looking at the top left corner, it's also showing us that the original mass of this was 276 kilos, and the new mass now is 101 kilos. Our mass reduction is 64%. So it's reduced the mass by 64%. Now from here on, we need to decide what we want to do. If we are happy with this shape, we can click on Promote Shape, and then it'll take this shape as a body and let us save it within the same part file or in a different STL file. Alternatively, if you're not happy with any of those things, you can go and modify your designs, and you can go and modify your boundary conditions, your constraints, and your loads. In my case, I'm happy with this, so I'll click on this button here that says Promote Shape. When I click on this, it's asking me now whether I should promote it as a shape into a current part file, or should I create a separate STL file. In my case, I'm going to go and say into a current part file. When I click OK, it now promotes that shape into a current part file. It tells me that you are better off changing your visual style to be able to see the shape. I'll click OK, and if I look at my browser tree, I can now see the promoted shape here. But because my original part is a steel component, I can't see the shape inside it. I might just go and override the appearance and make it a clear, let's say a blue clear component, and there you can see. So the blue clear component is my actual model, and the yellow bit is the shape that Autodesk shape generator recommended we should be using. I can also expand this here and right click on this mesh feature and say show mesh edges. It will now display the model as meshed edges. You can right click on this, go properties, and change the appearance of this. So if I go and change this appearance to, let's say, zinc or something, it now changes it to this appearance. So from here on, we can use this as a guide to create some cut features for material removal. Basically, what I would do is I would simply go and define a new sketch on the front face. I'll draw a circle and then just an arc, so a 3-point arc, let's say, starting somewhere here, going up to this, and starting somewhere. Or let me just quickly go and say project geometry. I might just project the outer edge here, just to get some basic stuff. So starting with an arc from somewhere here to this, I just cut it here. And then again, starting an arc somewhere here, going up to. So all we are doing is we are just modifying this shape to match what we need. Might apply a tangent constraint between this and this. So what I've done is I've created this little region that I want to remove. I'll make sure that I've applied the right constraints. And if I go 3D model, extrude, I can select this bit here, and so I want to cut all. So I'm just removing that bit, or alternatively, I can go back into my sketch. As I said, the whole concept from here is for you to be able to decide what you want to do with this shape. I could go back and say, you know what, I might just start on the arc from here, go up to this, and then we just start a new line. Take it up to this, come down, go around this, further here. So I'm just using this as a base to modify the shape. It doesn't have to be accurate. Then I might just use another project geometry. And apply another coincident constraint. So I'm cleaning up this entire shape now. And then 3D model, extrude. To this edge here, I can now apply a fillet. A bit more. And I can do the same thing in here as well. Just going to this face again, defining a new sketch. Because this is just a conceptual design at this stage, I don't have to worry about the real cuts and so on. I can later on go and create fillets all around this. And then going all the way up to this here, just do a tangent arc here. And then finally closing this shape. I'm just going to apply a tangent. So I'm happy with this shape right now. Finish sketch, do another couple of extrude cuts. And then finally, I can go and add fillets to all these corners. And then if I turn off the visibility of this, so this is now a new modified shape. Once I've got this shape, I can take it again into my part modeling in my stress analysis environment, and I can test this for further stresses. Alternatively, I could, let me just go and modify this as well to add a couple of fillets here as well. Alternatively, I could take this into programs like Nastran and CAD and so on to further test for buckling and so on. I use this part for buckling analysis as well, and most of the buckling that I saw using Nastran and CAD was in this particular area. So the whole concept is from here on, once I've got this optimized shape, I can take into Inventor FEA or further into Nastran and CAD or other programs to basically test how it would behave under further loading conditions. Now, one of the questions that I was asked some time back is that when we originally optimized this shape, we only optimized it for static linear loading, whereas in actual front loader buckets, it's not just static linear loads that are applied on this. There are also additional loads applied when it's moving around. So at this stage, as you could see when I did the shape generator, it only allowed me the static linear stresses. It did not allow me the non-linear loads and so on, or dynamic loads. So at this stage, we can only test it for static linear shapes, but the whole concept is once you get the shape right, then you're able to take it into other programs like NASRA and CAD or Simulation Mechanical, and then run the nonlinear and the dynamic loading on this. So that's pretty much all I had to show in this particular webinar. We pretty much, I wanted to finish it within about half an hour, 40 minutes, so it's pretty good. We have finished it on time. So now I can open it for questions. So if you guys have any questions, there's a chat window there. Please click on chat window and you'll be able to type in questions. I can see that John Neville had raised his hand. John, if you've got any questions, please just type the question in the chat window. I'm open to taking questions now. So Andrea has a question, does shape generator work for sheet metal part as well? So Andrea, if I just quickly show you this here, I'll start a new sheet metal file. If I just quickly create a face. So in here, we don't have the shape generator tool available, but if I go to the 3D model tab, that's where the shape generator is available. So the shape generator is not on the sheet metal tab, it is available on the 3D model tab. So if it's a complex shape, so if I just quickly go and change this to, I'll just add a couple of flanges as well. So if I go into my 3D model, I can go and say shape generator, define whatever my fixed face is. So that's my fixed face. And if I want to apply a force on this of, let's say, 100 newtons, and then generate the shape. We didn't pick any preserved region area, so I have a feeling that it's going to be a funny result. I might just cancel it because I haven't picked any preserved region. So because I haven't picked any preserved region, what would happen on Rare is that it might remove this face or this face and so on. So if there are some regions that you want to preserve, you can click on preserve region, pick the faces that you want to preserve, and then when you run the shape generator, it will give you the optimized shape. But the key, as I mentioned, is to make sure that you click on preserve regions. I haven't tested it. Have a go at it, Andre, at some stage, and then let me know how you go. Any more questions? All right, so doesn't look like any more questions coming, so looks like we are right on time, 1:30. So thanks everybody. Thanks for taking your time out and attending this session. I am recording this session right now, so if you or anyone in your company wants to watch it again, you'll be able to do that. Just shoot us an email, and we'll be able to share the recording of this webinar with you guys. All right, thank you. Thanks for your time.